if we look, there are two examples here. One of our examples has a variable inside of a log. And one of our problems has a variable inside of an exponent. Now, in order to do what I like to call undoing a log, because to get the variable out of the log, we have to undo the log, we're going to have to perform the opposite operation. What is the opposite operation of log? Exponential. So that's what's happening here. They're taking they're taking this original equation, and it's called exponentiating both sides. Basically, all it means, it's a big word for something really simple. All it means is we take what was previously there and make it the exponent. Now, our base here is 5, so I'm making log base 5 of 3x over 2 the exponent on a big base of 5. Whatever I do to one side, I must do to the other, so I'm going to make a big base of 5 on the other side as well. That's what's happening here. This is called exponentiating. Basically, we're performing the operation of exponential. Now, what do you think happens with 5 raised to the power of log base 5? They cancel because they're opposite operations. So you're left with just 3x over 2 equals 5 squared, which is 25. This is how we undo a log.
Is that like the final form?
And then you keep solving for x.
Oh.
Now here, we have a variable in the exponent. In order to get rid of the variable in the exponent, we have to undo the, what the heck am I trying to spell here? Undo. Undo exponential. I'm not going to have room to write that full word. How or what is the opposite operation of exponential? Log. Now we have to log both sides to undo the exponential term. What is our base in this problem? 2. So what we did was we log base 2 both sides. What do you think happens to log base 2 of 2? Cancels because they're opposite operations. And we're left with just 3x here. I don't know what happened here. And then we just continue solving for x. This is just a quick little intro into how you should be approaching log and exponential problems. I'll be doing this some more, don't worry. Okay, so now let's take a look at what we did last class first. Here, I'm not having to undo a log because I don't have a variable inside of a log, right? I just have a log and I'm trying to evaluate it. What question do I ask myself? What power do we raise 6 to equal 36? What power? So if I was to write this as an exponential, this question would be, what power am I raising 6 to equal 36? 2. 6 raised to the power of 2 is 36. And I don't know why they did this, but here, look, this is the exact same problem. What power do we raise 6 to be 36? That's what we did. That's what we started to do last class. So now, what I'm starting to show you today, what's different about the problem we just did versus number 2 here? We have a variable inside of a log. I want to point out that this is not log base 6 times x. This is log base 6 of x. We are logging the x. I can't just divide by log to get the log off of the x. Yes? No. It's just, normally there's parentheses if there's 2 terms being logged. So if it had been log base 6 of x minus 1, and x minus 1, like the entire thing is being logged, then there would have been parentheses. But here we're just logging the 6. In order to get the x by itself, you have to undo the log. What is the base on this log? 6. And what is the opposite operation of log? Exponential. So we have to create a big base of 6 on both sides. Big base. Big base. What happens to the 6 raised to log base 6? And you're left with? And what? Yes, exactly. What is 6 raised to the power of negative 1? And I'm done. So just one more. I'm going to help you set up one more. This one right here. How would I get or start getting x by itself? You take the base of 2 and you do what with it? You make the big, I like to call it, you make the big base. You exponentiate by making the big base of 2 on both sides. All right, I'm going to have you guys work with your groups now. And you're going to do, so this was 1, 2, you're going to do number 3, 4, 5, 6, 7, 8, and 9. And then we'll stop, we'll pause there. What did you notice about number 12?
It was the exponent value. Oh. It's the exponent.
Ah. What happened here mathematically was ln and d canceled each other out, and we're just left with a 4. Now, what does ln stand for? Natural. Does anyone know? Oh, so I know. So look, it's a natural log.
Oh, it is.
But they decided, oh, we want this to look more like a log, so they flipped the letters. So instead of it being NL, they did LN.
Log natural.
Now, does anyone know another way to write LN?
E4. 2.E2.
Log base E. Log base E. Does anyone know what E is?
2. 2 point something. Natural log? 2 points. Yeah.
It is.
2 points. 2.7.
It's irrational. It's a number. But does anyone know its name?
E.
Yes. Some people call it Euler. Some people say Euler.
Euler. How's that?
Why can't we call it like
Now, shh. Now, the reason why log of base E is called the natural log is because Euler's number E appears in nature. This is like a really crazy phenomenon that multiple times in nature, in the natural world, scientists and mathematicians have discovered that E pops up.
It's like,
what do you
So when you think about population growth or bacteria decay, the rate at which these things decay or grow includes Euler's number. It appears in nature. That's what I mean when I say it's a natural number, which is pretty rare, right? Numbers just don't appear in nature over and over and over again. But Euler's number is different. That's why it's famous. Now, we're going to go more in depth on that on our application days. But you just need to know, you don't need to know any of that. What you do need to know is ln and e are opposite operations. They are inverses. So they do cancel each other out, leaving us with a 4. Same thing happened here on number 16. No, the parentheses don't do anything. So here, log base 7 of 7, what happens? They cancel now. You may be wondering, okay, great, they cancel, but isn't that 8.9 still an exponent? You weren't wondering that?
No, not really.
Okay, it's all right. So look, one of the log properties that we're going to go over today is that when you have an exponent on the term being logged, another way to write it is with the exponent instead as the coefficient on the log. So then, log base 7 of 7, that canceled to be what?
No way.
But itself, log base 7 of 7, what is that? 1. So then 1 times 8.9 is how much? That's really why we're left with 8.9 here.
Wait, so what if it wasn't log 7? Let's say it was like log 6. You can't do that, right?
Okay.
No way.
Oh, no, you couldn't.
Yeah.
You're right, you're right.
So it'd be like,
It's only because the base matches. All right. So now,
2 not 0. My calculator keeps 0.
I need to show you how to solve these. Instead of undoing a log here, what am I having to undo? Exponential. Meaning I need to ask myself, what is the opposite operation of exponential? Log. Now I keep the same base. What's my base number here? My base is 2. So I'm going to take log base 2 of both sides. Log base 2 of 2, what did we just learn happens there? Cancels to be 1. The x actually comes down out of the exponent. And I just have log base 2 of 128 is what x is equal to. What power do you raise 2 to equal 128? 7.
wait, how do you say 7?
What?
Because
7 times 2. 2 times
No.
7. 2 times itself 7 times.
Right.
the
The people that answered had already done this.
Oh, okay.
Yeah, I did it.
I mean, unless you have these memorized in your head, I did not know that 2 raised to the power 7 was 128.
You should memorize what 7 is.
Go ahead
I know 2. No, I accidentally did this question before. Never mind.
and do 14 and 15 now. Do 14 and 15. Now, because log and exponential are inverses, a lot of the log properties are similar to the exponent properties or exponent rules. So before we go over this, I want us to look at the exponent rule that's similar to this log rule. If we have x to the nth power, or I'll do m, x to the nth power times x to the nth power, what does this become?
X to the 4th power of n.
Not times, plus.
I got distracted by the phone.
This is because, and if you're curious, if for example you had x squared times x to the 4th power, how many x's is this really? 2, right? You're multiplying x times x to get x squared. How many x's is this?
4.
How many x's is that?
6.
6.
That's what I was thinking.
That was my exact thought.
I said 2, and then someone else said 1, so I was like, oh, 1.
All right. So the log rule is not exactly the same, but it's similar. If we are logging two terms being multiplied together, I can create 2 logs with the arguments separated. And what operation do you think is happening between the 2 logs? Addition. Addition. Just like when we're multiplying exponents, we can add them instead.
Oh, it's like
Same thing here. Right. Same thing here. And it's flipped because they're inverses, right?
Yeah.
Same thing here. If we're multiplying, we can split it apart by instead adding them. Yes. Wonderful. So my next point was, notice all 3 of these have what? Same base of B. In order to apply these properties, you must have the same base. So let me do the kind of middle hard problem. I'm going to do number 2. And then I'll do number 4 as well. So number 2, what we're doing is we're trying to condense from 2 logs into 1 log. So condensing is taking 2 or more logs and combining them into a single log. Expanding is when you take a single log and expand it into multiple logs. So here I'm trying to condense. How do I take 2 logs with the same base that are being added and condense into 1 log? You multiply the 2 arguments. So we're going to have log of 6 times x minus 3. I'm multiplying the 2 arguments together. But then we do have a little bit of simplifying here. What do you think I have to do inside of the log? You have to distribute that 6. So we have 6x minus 18. And that's my final answer. I have condensed into a single log and simplified. So now I'm going to expand. I'm going to take log of 72, and I want to expand this into 2 logs. Meaning, I'm trying to think of 2 numbers that will multiply to be 72. What are they?
9 and 8.
9 and 8. You can choose multiple. You can say 1 times 72.
No, 9 and 8.
You can say 4 times
Elementary school, bro.
4 times 16. So then how would we split this into 2 logs?
It would be log, and then just put numbers in.
9
Log 9, log 8.
So log
Plus log 8.
plus
Log 8.
log 8. Good.
Oh, wait, hold on. I was
Big
gonna
brain.
do it different. So wait, here you multiply.
So you guys do 1, 3, 5, and 6. Take a breath. Everyone breathe with me. If you're breathing, you're not talking.
You're not breathing.
Are you breathing? Okay, next property. I'm going to probably go over 2 properties at once right now, just so that we can make sure we finish on time. The quotient property first, just like before, we're going to look at what this property looks like with exponentials. If you have x to the nth power over x to the nth power, how can you simplify this? Yes. So this becomes, now which one comes first, the m or the n?
And
The the numerator exponent goes first minus the denominator's exponent. So here, if I'm trying to take this log base b of m over n, how do you think I can expand this?
Log base m minus log base.
Right. We take the log of the numerator minus the log of the denominator. It must be in this order. Addition, it didn't matter the order. Subtraction, it does matter.
How come you can't just write log and then base m minus n instead of?
Because this does not just turn into m minus n. It is division in a single log. But we can split it into two logs by subtracting the logs.
What happened to the numbers?
Yeah, we just got letters though.
So now, let's look at this one here. How can I rewrite ln of 96 minus ln of 6? And what is 96 over 6?
We had to go 16.
Oh, never mind.
They're cheating.
I got it.
On number 10, how would you expand ln of 3, ln base, oh my god, ln. Log base 3 of 8. How could I expand that into two logs? Yes, you can make 8 be division by making it 16 over 2 instead. And then we can do log base 3 of 16 minus log base 3 of 2.
You need to expand it out.
Wait, why'd you do this? This is so excellent.
Yeah, why don't
You
you put 8?
unsimplifying.
Remember, we're doing properties so that we can solve harder problems next class. You're going to need to know these properties in order to solve for x
Oh, I wrote that
next
all.
class.
So like it's good that we're like simplifying it.
Yes.
I never thought that.
It's like, no, I don't know about that. All right, and lastly, I am going to have you do these problems, but I want to go over this last property. It's actually the easiest property. I've already gone over it. When you have an exponent on a log, how else can you write that? You bring the exponent to the coefficient. So here, if I'm trying to condense this into a single log instead of a coefficient and a log, what would I do? So what does it become?
6 times 3.
6 cubed.
6 cubed.
The base here is still 10. Okay, don't bring that 6 into the base. The base is still an invisible 10. But it is 6 cubed. What is 6 cubed?
18. I mean, shoot.
216. What about here? How would you expand this? Number 16.
X times log 2.
Good. Log base 2 of 5, we say.
What's the difference between a